I'm going to do a couple of videos on rational functions. Probably going to end up being about 3 of them. The first one I'm going to do is just on the rational function in vertical asymptotes. And rational functions have this form here. They're just a ratio of 2 polynomials. So in the numerator I have a polynomial, and the denominator I have a polynomial. So things that we've been doing with polynomials are now going to get a little more complicated, because now we're talking about ratios of them. And the first thing that is different, as you read your book and look at the pictures of these rational functions, many of them, most of them, not all, but most, have vertical asymptotes. And the vertical asymptote is just an imaginary vertical line. If you graph it using technology, it's not going to be displayed, but it's a line that the function does not cross. And the reason it doesn't cross it is because for those x values where the vertical asymptote occurs, the function is not defined. So an important example that's going to keep popping up is this one right here, f of x equals 1 over x. It's a hyperbola, very simple hyperbola. But when you look at this, there's one value I can't put in for that x, and that is 0. So I'm going to write the domain in this very short format, all reals except 0. So I could have any real number I want in this function except 0. That 0 is telling me where the vertical asymptote is probably going to occur. In this case, the function has a vertical asymptote at x equals 0. So when I did this in class, I did a graph and derive. This one's in the book. You can go ahead and find a graphing utility and try graphing it yourself, or come in and I'll help you with it. Second example, f of x equals 7x over x minus 9. Okay, so this is a little more complicated, but when I look at this, you're still going to just pick out what the domain is. The domain is all real numbers except 9, because if I put 9 in there, I get division by 0. So this function is going to have a vertical asymptote at x equals 9. Here's another one, a little more complicated again. I'm giving you a caution here. You may have to factor the denominator, make it look like this. Your homework, you're going to have to factor some. This one I factored for you. And when I look at these two factors, I see there's 2 values that could give me 0 in the denominator. And that would be positive 2 or negative 3. This function has 2 vertical asymptotes. So one would be at x equals 2 and x equals negative 3. And it's important that you recognize x equals 2 or x equals negative 3. Those are equations of lines, in this case vertical lines. Again, there's a graph, not this particular one in the book, but it'll be similar to what I did in class. Okay, major caution. Major caution is this book does not really mention holes, and they're going to still ask you the question, is there a vertical asymptote? Well, sometimes you're going to identify something as being a possible vertical asymptote, but it's not. The function is still undefined there, and what it's called is a hole. And the book doesn't talk about that, but they do ask you if or if not there's a vertical asymptote. So if there's not, there's probably a hole. So if I look at this example, f of x equals x squared minus 4 over x minus 2, if I factor the top, you notice right here these 2 factors will cross off. Now, I do my domain of this one before I start reducing it. My domain here is still all real numbers except 2. So something is happening at x equals 2. Well, when I cross all these x minus 2's, I'm left with right there just x plus 2. That's what this equation is actually going to look like. If I graph this ugly looking thing here, all it is it looks like an equation of a line, except at positive 2. Because in the original equation, positive 2 would give me division by 0. Well, positive 2 would also give me 0 in the numerator. If those factors cross off, it's not a vertical asymptote, it's a hole. And if you graph this, like I did in class, you'll actually derive will show you a hole in the line. So no vertical asymptote. You need to always check that. On these ones up here, they're simpler. But what you can always do is find your possible vertical asymptotes and go back in the numerator and make sure they don't make it 0. None of these do. This one, if I say, ooh, x equals 2 is going to be a vertical asymptote, well, if I plug it into the top here, I get 0. It's not a vertical asymptote. It is a hole. Okay, so that's the end of this video, and next one will be on horizontal asymptotes.